Okay. I do have to apologize. I actually have to apologize twice because I hate when people apologize at the beginning of their talk. It really sets the right tone. But I have to apologize because I had to cut about half of my presentation out, despite ridiculous mythical efforts. I can't do my demo today, so that will come later. So for now, we'll do the parts that remain, which are still pretty interesting. And because it's so much shorter, I would encourage folks to interrupt me often with any questions that you might have as we go along. So what I'm talking about today is this thing called network flows. Who actually knows what that means and maybe even has used those in anger? Not many folks. This does not surprise me. This is typical of the world in general, that this amazingly useful tool is known by almost no one, used by even fewer. And there are a variety of reasons for that. But let's start off by talking about what they actually are, and why you should care intensely about them and fall madly in love with them as I have. So you should care because visibility makes your life easier. I would assume that most of the people in the room do operations of one sort or another, and as infrastructure operators or application operators, the more visibility that you can get into your whole stack, the better that you can do your job, the faster that you can identify problems, the faster that you can repair your infrastructure. And so you want more visibility. And that's what network flow data gives you. It gives you this amazing microscope and telescope. And think of any other equipment that you want to do monitoring on your network. This is better. You want to do DDoS detection, you want to do capacity planning, you want to do traffic management. Any of these sorts of things that require really detailed knowledge of what's actually going on in your infrastructure, network flows give you that. So first we're going to talk about sort of in general what is going on the network, and then how do we package that into something that's actually interesting that we'll call a flow. Okay? So first we have this dark blob. We'll call this dark blob, which is strangely appropriate in this case, your network traffic, right? It oscillates up and down. What is it actually? Well, we don't know. There's a bunch of things that are in there. Maybe it's packets, maybe it's bytes. Who knows, right? Where is that going? I don't know. But it goes up and down, and so that's probably a pretty interesting thing for us to monitor, I think. But let's zoom in more on that. What is actually going on in there? Well, there's these streams of packets flowing back and forth between who knows where, different hosts in your network, hosts in your network, and hosts in far-off lands. And that is a bunch of streams interweaved into each other. They're our statistical multiplexing friend. And as we again zoom in on what that is, well, we have these packets, right? Those streams are actually these little packets, right? This is a lot like when we start zooming in and we zoom in and zoom in and we see cells and then we see molecules and then what do we see next? So we've got these packets and we actually have this header and this payload generally, and that header is stuff that we need in order for the packet to get where it's supposed to go, for us to tell what's in the packet, etc. And so for common stuff that we all deal with every day, IP, what does that mean? It means it's protocol and source and destination IP and source and destination ports, and there's a bunch of other stuff in there, but we'll just focus on these for now. But then we've actually got sort of the dynamics of these things. We've got these streams, we've got these packets, but they are not at rest. They are in motion. And as they move through the infrastructure, They may get spread out from each other. It may take a while for it to move from one point to another, right? So we have our latency, which is how long did that thing take to get from wherever it started off to wherever it was going. That's a useful thing to know. So we heard a lot yesterday. There is direct and really powerful correlation between the latency for you to deliver service to your customers and how engaged those customers are. So latency matters. Let's measure that. Well, there's more than latency that's interesting here. We've got the variation in latency, right? Over the life of this stream of data, as we've got packets moving from one host to another, they don't always take, say, 50 milliseconds. Sometimes they take 50 milliseconds, sometimes it's 55, sometimes it's 40, right? That variation is jitter. And some things don't really care about jitter. If you're doing backups, probably doesn't matter. If you're doing voice over IP, this is almost the only thing you care about. If you have just enough bandwidth and your jitter is completely flat, you're probably going to have a better experience than if you have tons of bandwidth and wildly varying jitter. So what you want to do, what your application is, what it is sensitive to, will determine which of these pieces are interesting to you. And of course, any interesting infrastructure is supporting a lot of different applications with a lot of different requirements, a lot of different sensitivities. And so often you don't have the luxury of just picking a few that you get to monitor. You have to monitor them all. When you have to monitor them, you have to monitor them all the time. And so the last bugaboo in this list is packet loss. And this is one that kills people sort of silently, in that a very tiny amount of packet loss, just minuscule, a fraction of a percent of packet loss versus something like TCP will drop you an order of magnitude in your throughput. And so you may look at aggregate statistics, at sampled statistics, and never see the amount of packet loss that is actually causing you this huge throughput impact. So again, enormous detail is actually required if you want to quickly zoom in on a problem rather than try and infer a problem over a long period of time. So, given that background, that this is what we are talking about, this is the network world in which we live. Let's talk about the structure of what formally a flow is. And when I say formally, I mean according to, in my case, the IETF RFC, the specification for a thing called IPFix, which is an open standard for flow export. But it turns out there's a lot of pieces to it. It's not just about export, although that's what people often talk about. So, the first step in understanding what a flow means is looking at these things that are possibly contained
called flow keys. And flow keys are the things that have to match often in a certain period of time for packets to be considered part of the same stream, the same flow, the same communication between, say, a pair of hosts. And so if they have the same protocol, if they have the same source IP and the same destination IP and the same source port and the same destination port, and it's in a certain amount of time. Now I'll come back to why that is, because it would seem that if you're watching a whole TCP session, for example, you know when it's done, and that notion of what time it is doesn't really matter. It starts at a certain time and ends at a certain time. But that's actually built into the protocol for certain reasons. So this is our keys, or in other systems you might consider them the dimensions. So there are all sorts of ways that these sorts of things get called out, but in IPFix, these are called flow keys. And it is simply a way of identifying flow. The language of the specification actually is really contorted and convoluted, and it's hard to understand what a flow key is often from reading it. That's all it means. If these things are equal, you're part of the same flow. Wow, that's hard to read. So, given that you've got these flow keys, you have these things called templates. And a template just says, I am going to export flows to you that are structured like this. It says, they're going to be this template ID up here that just says, when I tell you template 253, you know that it's going to be structured like this, so you can parse it, so that we don't have to send every single time all of the information required to disassemble the record, because it's just this binary chunky thing, right? We're not talking about something self-describing like JSON. You then have the flow keys, as we just described, and I keep using this set of 5. That's just the most common thing that you see used as flow keys. There's actually just an enormous number of things that you can use here. You can have the source and destination MAC address. You may choose not to have one or the other of the source or dest if you're interested in doing it that way. Whole slew of things that you can put in there. I'm only focusing on these 5 because they're very familiar. Those are the most common ones. These things that you can't see down here, I'll pretend that I can read them. So this says total octets. This here says total packets. This says start time, and this says end time. And what this is these are sort of the data that you are collecting. Given that all of these things match, collect a certain set of data. I want to know, for this flow, right, because it's time-bounded or sometimes protocol-bounded, because we may know those boundaries. Tell me all of the octets that move through there, no bytes, but we're in networking land, so we call them octets. Total packets, and then the start and end time. There are various resolutions supported by the system. For that, the most common one that you'll see there is actually microseconds. So what we're talking about is microsecond resolution. This flow started at time X, ended at time Y, sent this many packets, sent this many bytes. Right? That's a really common setup for that. Again, all kinds of stuff that you can have in here. You can have unique flow identifiers. There are ways to actually inject things like jitter, latency, packet loss. So you can associate all kinds of information with this. And again, this gets described in the templates and then it gets exported as flow records. And the flow records say, hey, I am structured like template 253. And that means that you care about my protocol. 6, TCP. This is my source IP, this is my dest IP, source port, dest port, right? This many octets, this many packets, start at this time, end at this time. So that's what our template looks like, that's what our records look like. They look exactly the same because that's what they're supposed to do. This lets you parse this when you receive it. So that's all the sort of low-level pieces. What is a flow actually, right? Do folks have questions about your high-speed introduction to what flows are? Yes?
So are there good use cases for leaving out dest IP?
Good use cases for leaving out dest IP.
Does that even make sense?
It depends. There are a number of variations of how the protocol can work. The sort of basic situation is that the 2 directions of communication are actually considered 2 independent flows. And so in those situations, often what you want is one of or the other of source and dest, and so you just say you want both. There is another mode of operation which involves what are called biflows or bidirectional flows, where both directions of a communication channel are bundled together as a single record and exported. There again, you know both source and dest. So I'm not sure what you might want to do with that. Often you want to query based on that. You won't do analysis based on just this source IP address. But only collecting one end would be pretty unusual. So the ecosystem of flows is really, given that that's how flows work, that's what you're actually trying to collect and export. How do you go about doing that? What are the actual pieces in that flow infrastructure? So the first thing of interest, and small digression. As it is a hyper-pedantic specification, the number of components with enormous names that are almost the same but not quite is quite large. I am pulling out the 3 that you actually care about. If you were implementing a, say, high-end backbone router that wanted this sort of functionality in it, then you might care more about the other features. In general, you don't. So the first thing is this thing called a metering process. And it is a process that meters. What that means is it takes in packets and does whatever the metering thing does, which is generally matching those packets against the templates, right? These are your flow keys. These are the pieces of information that I want to collect. Collect those things, and periodically, or when it is appropriate based on the state of a given flow, export that information. That's what's going on over here. We're taking in these packets, doing our metering business here, matching things against flow keys, collecting the metrics of interest, and then we are emitting this stream of records. A meter operates in what is called an observation domain. A little less obvious what this is. So an observation domain is a set of interfaces, essentially sources for packets that go to a given meter. So if you've got your host with 3 Ethernet interfaces and you're running a meter on that host that is taking packets in off of those, that host is essentially your observation domain. But from the perspective of the protocol, that set of interfaces is actually the observation domain. They're so often exactly the same thing that it's not so useful in almost any situation to distinguish between them, but just so you know, they're not quite the same thing. And then the last interesting piece is this collecting process, which almost everyone just refers to as a collector. And a collector takes in these streams of flow records from all of your meters so that you can, one would hope, do something useful with them. Now, you'll notice conspicuously, there's nothing over here. So we're taking in all of these flows, and then what happens to them? Well, this is not really covered in the protocol. So here you are collecting all of this fantastically rich, incredibly valuable information, potentially a fire hose of it. How you actually store that, manage that, analyze that, make any useful decisions whatsoever based on that, sort of an open problem. Now, generally what you do is you pay someone a significant amount of money to purchase some appliances that you put into your network that tell you what happened in the last week or so. Because again, it's a lot of data. Often those are canned reports because it's a lot of data. But it is better data than you will get off of any other source short of just doing full packet capture, which some of them do, and protocol decode, which some of them do. But of course, as you try and move up that stack and decode everything moving across your network in that way, you very quickly can cross over that boundary of diminishing returns. So the flows themselves, so just that summary information for a given connection, tends to be that balancing point, that tipping point, where if you start doing packet capture and looking more deeply into the packets, you have to be looking for something very specific. It's not quite the slam dunk that having flows at all is. So, given that those are the pieces and that's what flows are, and this is how awesome network visibility is, how do you actually do this? So, the meters themselves will historically run on the actual network devices. This is what it was designed to do. These are the people by whom it was designed. So the original flow stuff came out of Cisco, no surprise. There's a proliferation of flow export protocols in addition to the IETF IPFix stuff. There's Juniper's S-Flow. Cisco's is called NetFlow. There's JFlow. I mean, there's just, everyone's got a flow thing. They all do the same thing, but slightly differently because that's really valuable. Now, because of the volume of traffic flowing through these network devices, the traffic itself is generally sampled. They can't possibly keep up with the available CPU and memory resources with the amount of traffic meant to flow through these devices, right? When you're doing 100 million packets a second, trying to do full metering of every single packet moving through the system is a significant challenge, right? That represents the aggregate of a huge number of hosts flowing through a single point in the network. And so you'll generally see sampling there. And that sampling may be 1 in 100, maybe 1 in 1,000, maybe 1 in 8,000. And so now it becomes clear why you want that time-based interval, right? Because if we see a whole TCP flow, we know when it starts, right? We saw that three-way handshake. We know when it ends. We saw that pain in that connect. But if we're only looking at 1 in 1,000 packets, it's pretty unlikely that we will see all 5 of those packets required to know when that single TCP flow has started and ended. And so to address that problem and still provide useful information, these devices depend heavily on timers to say if this flow ended or started or ended at these given times. It's not a requirement for all devices to operate that way, but that's the history of these things, that they start off in that mode. So you can get dedicated appliances, as I mentioned, and these are generally things that attach to switches or hubs, and all traffic is mirrored to them. And in many ways, they act as a proxy for some other thing, whether it's the network devices themselves or it's the end hosts, so that they collect that data, generate flow reports, and send it off, and none of that load actually was really on the switch or the router that was involved. So that's really useful. It tends to be a little bit expensive. There's obviously a broad range in that sort of pricing. Storage on these tends to be very limited, and again, that's a concern because this data is rich and valuable. It's also just big. And you can also run it on the hosts. Again, where does the data go? Because when you run it on the hosts, you generally have even more data than when you run it on the network devices. Because hosts tend to have not that much bandwidth comparatively, right? Compared to, say, a core router with many 10 or 40 gig interfaces. Your one host with 1 gigabit Ethernet connection that you really only ever push 1 megabit on has a massive amount of CPU and memory compared to the tiny amount of network traffic that it has. And so, in the spirit of the internet, pushing everything out to the edges, this is great. But now I have a new problem, which is I have this fantastic unsampled data off of my host, and it scales as I add hosts, but I don't know what to do with that data. So the classical view for networking has looked the same for a really long time. I don't know if folks started off using MRTG and moved up into the big bad world of RRD tool that looked exactly the same and allowed you to track one metric against time. It looks like this. Only lots of them, hundreds of them, digging around looking for the thing that's actually broken right now. So what's this? I don't know. Where is that data going? It's just a big block. It's our big opaque blob from the beginning, right? This is how people see the world when they look at their networks. This is in fact how they have seen the world when they look at their networks for at least 15 years. This is not great. So where is this data going? Could be to other hosts in the network, could be to hosts outside of the network. Is it backups? Is it a DOS attack? indistinguishable, right? Where is that coming from? Because it came out of nowhere. That's crazy. What is that? I have no idea. Because I have no visibility, right? This tells me a little piece of information, but it is so heavily aggregated that all the useful dimensions have just been squeezed right out of it. So all that flow key stuff, the source and desk IP addresses, what protocols this is, right? All the stuff that would allow you to just zoom right in on what the problem is, have just been eliminated completely. Now, this is not a crazy thing to do because this doesn't take up much space. And so when you have a bunch of network devices and you don't want to have to pay for a lot of storage and a lot of people time to manage that storage and figure out how to do analysis, this is great. You know? Now, if your primary concern is keeping your infrastructure running and troubleshooting problems really quickly, this is not so great. And as a tiny anecdote, when I started at Amazon, this wasn't even there. How many switch ports in the network of thousands of machines did we monitor? Come on, this is an easy one. None. None whatsoever. So, if something was overloaded, if something was dropping packets, if something was experiencing lots of errors on a given port, we had no idea. And so moving from that world, where we are the best in the world because we're Amazon, and we have no visibility into our network, to installing something as frankly dumb as Cricket, which looks like this, because they all use the same code for their graphing, in which suddenly we could actually see it. And our troubleshooting time went from days or even weeks trying to track down where a problem would be in this crazy, organic, wild network of thousands of machines that could not possibly go down because we would lose lots of money, to minutes if we were lucky, but more likely hours as we looked around through all of these graphs, but thank goodness we had them. And that sort of order of magnitude compression in time to find a problem, fix it, hopefully identify it before it even becomes a problem, is the sort of thing you see when you move from this world, where you may have hours trying to figure out what's going on, to the flow-based world, where generally you see things as they are happening. And that is transformative, but not easy. So the flow view of that world starts looking more like this, where you can actually say, this host is sending a bunch of traffic at this specific host. Why is there lots of traffic in and out of this host? It is talking to this one and this one and this one. You know exactly what is going on, right? This is the world of flows. This is nothing like operating a network when all you have is RRD tool. The problems just jump out at you, right? If you want to know where in the world that traffic is going, you know immediately, right? These are the questions that you can ask because you have not compressed the hell out of it from this, right? You have all of the data. It's still there. But there's no free lunch. I don't know if I mentioned it, but that's a lot of data. All of it. All of the data. So often you're looking at more than 1% of your total traffic, that's flows. So if you're pushing 100 gigs a day through your infrastructure, maybe you're doing backups, as people often do, and this is just communication within your network, you can expect to generate more than a gig a day of flow data. And that adds up pretty quickly if you want to retain it, if you want to analyze it, right? That's a problem. Lots of space means lots of storage expense, or it means that you're compressing stuff, you're doing that aggregation that we saw earlier. And maybe you know the questions that you want to ask, and you can do that compression down for older data. Or you're truncating it, right? You're saying I'm going to keep a week's worth of data at really high resolution, and then I'm going to chop it off. I'm not proposing that any one of these is better than any of the others, by the way. Different ones make sense in different situations. But you should be aware that this is the trade-off that you have to make. This data is really high dimensionality. So we just looked at stuff that has 5 dimensions in our keys, right? Those flow keys, we've only got 5 of them, all those are dimensions. But there's all kinds of other interesting dimensionality that can be attached to that stuff, right? If you want to actually see the geo information, then you probably want lat long attached to it. If you want to know what other ASs you're talking to, what other autonomous systems right out on the internet that you're talking to, that data needs to be attached. Right? If you want to know what prefix this is, not just which the IP address is, that needs to be attached. And so all these sorts of things balloon out your dimensionality. And as soon as you do that, it becomes much more challenging to query because you have to potentially do some very complicated join operations across all this information. So flows are not free. And so you generally have this choice between stuff that is inflexible and kind of limited in what you can do, or it's really expensive and kind of complicated. And by expensive and complicated, I mean major service providers will spend millions of dollars to deploy flow infrastructure and then pay 1 or more engineers to do nothing but operate it. So that's pretty prohibitive, and that's why most people haven't really heard of it, just because most folks can't pay millions of dollars and dedicate engineers just to doing this, as awesome as it is. So between this and this slide is where all the stuff that I cut out was. So I apologize again. It's abrupt. That was really rough. So some stuff that is probably of interest, and I hope that these slides get posted because I always hate when people put a bunch of incomprehensible URLs on slides. This is really useful, and then let's move on. This is the IPFix working group. So if you want to actually read the specifications, and despite being hyper-pedantic, which is great in the specification, but not great for reading, this is the place. These are some of the sorts of tools, sort of a broad sampling of what you'll typically see in this space. So you've got this thing called nprobe, and if you've ever used ntop from the same folks, and it is at the lower end of things, and is intended to be run on a machine, and you attach it to a mirror port on the switch, and it can then do that sort of appliance-based flow generation that I mentioned. Cisco, of course, knows a thing or two about doing flows, and so they have this collection engine thing. As is often the case, Cisco has made this cool thing, and then other smaller companies have gone off and done much more interesting things with it. One of those companies that I've actually got a lot of experience with, and they make good stuff, even if it is millions of dollars, is Arbor Networks. And this is especially fantastic if your problem is denial of service attacks. That is their specialty, and they are very good at it. And then somewhere in the middle of where those actually get deployed and how much they cost is the stuff from Dartware, the intermapper. And so this is a small selection. There are actually dozens of products in this space. And so there's probably something that could fit your needs if you're interested in using flow data. And finally, there is our stuff, which is called Fast IP. And we do this as a service. So all those hard problems of keeping around your data and doing analysis, we do for you. You are encouraged to go and sign up for our beta if that is of interest to you. And it is, because you're awesome network operations folks. And that is everything. Yes?
You mentioned the 3 different sort of methods of collection, like the network, the span border, or those.
Yep.
Is one better than another in different situations?
Absolutely. Yeah, that's a good question. Often you can't use the span or mirror port based approach because there is no point in your network where you could put one device and get that data. And so you have to deploy a bunch of them. And so if that is not feasible for you, then that's not a great approach. On the other hand, it's much more common to get really useful features like full protocol decode. So there's a company in Seattle actually called ExtraHop that does really amazing stuff with full protocol decode. So they can do things like detect that you are having a bunch of a certain kind of MySQL error because they are decoding the entire MySQL protocol off of a mirror port. But again, if you can't have a single point in your network where you can put that, you have to get a bunch of them. The router or switch-based approach, kind of hit or miss, whether you can get the functionality that you want for flow collection or flow metering and export on cost-efficient devices. It tends to be a higher-end feature. It's been moving down the sort of the cost chain into the less expensive devices, but it's still not as fully implemented in the lower-end devices as you might like it to be. Features that are typically missing from the network-based devices are things like secure export over TLS, which is part of IPFix, not part of NetFlow or any of the other vendor specs that I'm aware of. But again, not generally widely implemented on the network devices. But the network devices are, of course, where your traffic is actually flowing, and so you don't have this concern about, do I have one point in the network where I can attach it? And the post-based solutions, the challenge there is, one, it's one more thing to manage on all your hosts. Generally not much overhead, but certainly there. And two, it generates a lot more data certainly than the network-based stuff. It's going to generate at least as much as the appliance-based stuff, and you got to figure out somewhere to put it, right? Which is something that the appliance answers for you. So those are generally the trade-offs. So it depends on what your goals are for your infrastructure, what it is you're trying to accomplish with the flows. You know, if what you need is full protocol decode, then you need one of the appliances that does it. That's just it. If you don't need any kind of really specialized feature like that, you have one. Mr. Alls.
So generally speaking, this flow analysis stop at layer 4, or?
So the spec really is focused on 4 and below. There is, at the same time, a lot of room in it for defining custom data types, custom things that can be used as keys, custom things that in particular can be used as data elements in the records. One example of that is the Carnegie Mellon CERT folks have a subgroup that does a bunch of flow stuff, and their meter has a module to do regex-based layer 7 matching, so payload regexes, PCRE, and then they use that to detect what layer 7 protocol they think is in the payload, and then they attach that information to the flows that get exported. So the way that they export those, or rather the format for those, is proprietary, but it's in the spec to do it that way. There's an enterprise identifier. We have one, they have one. You put all of the proprietary stuff in that namespace, and it's good to go.
I have another question.
Yes.
So for all the products, you even have IP. In the scenario where you have your template and you choose 3, 4, 5, however many value flow keys.
Yes.
If, and maybe this is product specific, but if you have a template and then you say, oh shit, I gotta add something there. Does that, generally speaking, at least across the products that you see, does that schema change? Will that match up, or will I lose a correlation with the data that didn't have those fields earlier, or is that a storage specific?
It is really specific to the products that you use. The appliances tend to just, and in fact, network devices as well, just have a fixed set of things that they will do. And you don't have that much flexibility. So like there's all of this flexibility built into the protocols. Even NetFlow version 9, which is what iFix is based on, has this amazing flexibility. It almost never gets used. And instead, there's just this fixed set, usually the 5 that I showed you, right, that we're most interested in. I can't speak for everyone. For ours, there's no problem with doing that. So if you decide you want to add something later, you can do that. But the constraint is generally going to be, here is the set of things that we need in order to provide useful service. And so things above and beyond that, that's a little up in the air right now. Not because we can't, but it's, prioritization. Questions? It's 9 o'clock, that's the problem, right? Because I was awesome. No? Nothing?
Wait.
Oh.
But Ben, that's a lot of data.
That is a lot of data.
How do you do that as a service?
Don't set them up like this. How do you do that as a service? You write it wrong a bunch of times and figure out what doesn't actually work when you try and manage that much data.
No, I presume that I will send the fast IP service data out of band.
The meter will actually just export directly to us over TLS, authenticated in both directions. So in terms of data ingestion, yeah, that one's actually the easy part. No one does that the way that we actually do it, but they could. It's not that.
If I'm collecting it, is it possible? Is it technically possible for me to backfill?
You mean, could you?
Can I backfill data if I know start and end time? If I have the collected data, let's say I do the effort of storing it myself, and then send you all my traffic that I collected last week.
Right. That is not how it's supposed to work. Which is not to say it couldn't work that way, because honestly, if you took a trace file and played it back through the meter, because it can do that, that would be legitimate data. But if your data showed up a week later than when it was actually generated, that could cause other oddities for us. But not out of the question. Be interested. Yeah, because things that actually have time locality are useful to have near each other. Not out of the question. It would be an interesting use case to have to see what it was actually for, other than messing with me at 9 o'clock in the morning. Not out of the question. Yes.
So I'm more interested in the host-based approach.
Me too.
Okay. So what tools did you use to get started on something like that? You had
Totally us. If you just wanted to go and set something up yourself,
try it out, test it out.
sure. The stuff from Carnegie Mellon, they have both ends of it. The total set of tools is called Silk. The group is called NetSA within CERT. And if you know academic C code, then that code will look familiar. And if you like good code, then you will not like that code. But in terms of getting started with it, functionality, it's totally serviceable. So that's where I would start if I wanted to just set something up myself.
So you're doing this all as a service. You've got all of
is still your data.
How do I get it all back?
So the bulk question of how you get it all back is currently unanswered because, you know, if you have 20 terabytes of flow data and you wish to have that delivered to you, doing that can be somewhat challenging. The general accessibility is query API that allows you to just ask arbitrary questions about your flow data, including drilling down to individual flows which are uniquely identified. So, sort of the quantum view of your network traffic.
And open APIs, everybody can write whatever language you understand.
Yes, whatever you'd like. Yes, sir. That actually depends on whether it is implemented in hardware or in software. So any platform that's doing forwarding in general in software, and those are far fewer than they used to be. But NetFlow in particular, so if turning on NetFlow, there were some platforms where turning on NetFlow would cause it to switch to software forwarding, even though it could normally do hardware forwarding. So that's really the massive hit that you took. It's generally pretty obvious from the sort of marketing literature whether you're dealing with something that does it in hardware or software. If it's doing the NetFlow in hardware, you can generally be assured of two things. One, it's going to be fast, and two, it's going to be sampled like crazy. Should we take a coffee break and then come back and ask more questions? Anything else that folks have hiding out? Yes, sir.
Is it possible to see actually what, an example, you said it works as a service, so can you show something?
Yeah, that was that section that's missing from the deck. Yeah. I did want to show people that this morning. It was not to be. Tomorrow morning, maybe. Yes, sir.
So how do you make a virtualization? Do you put the computer on the hypervisor or on the VMs? Or?
So there are a number of answers to that. The really simple answer, and the one that we use on EC2, is you just put the meter in the VM. Because generally that's actually what you're interested in. The answer that in some ways I like even better than that is to put it into the vSwitch. So you don't actually worry about what's going on in the host, and in fact you don't even have to trust the VMs with the information that they're exporting to you. That software does not exist yet. But that actually is definitely my preference. And that's towards the put it in the hypervisor. You can certainly put it into your DOM0 if it's actually going to see all of the traffic. That may require putting the physical interfaces into promiscuous mode, depending on how the network actually works in your hypervisor. So, simplest thing right now, put it into the guests. More questions? All right. I'll still be here if folks want to harass me later because they were too embarrassed to ask something in public. Okay?